what is B, what is C.
Yes, yes. So actually, if this is actually when the equation, whatever this number, when this equation is balanced, then what you need, if you see this formula, it's only B and A.
Yeah.
You don't have to do anything with C.
C or
Because it's actually this calculation actually initially it involves C and then C is transformed into back into A and B. So this is the end result.
Yeah.
Okay? And if you want to use the lanthanum dihydrate, it's something like this, and this is more general.
Okay.
I will give you this.
Okay.
I will send you
Okay.
this, Dr. Mina and Dr. Ansari. But what I want to show you is this. Using those equation, then I made this. Okay. You see, for example, this one, LaH2. So I made this Excel. Okay, this is the volume of the milling jar, and this is the weight of LaH2 in kilogram, and this is the in gram,
LaH2.
and everything you just use that. Do you understand?
Yeah.
That
Yes.
formula.
Yes.
What you need is actually this. What you need is actually this.
This one is the density of lanthanum. This one density.
Yeah, this is the density of the
Density.
It's
lanthanum
fixed.
dihydrate.
Yeah.
So actually you don't need that. Actually you just simply make this. For example, okay, you put this.
Yeah.
Okay,
Weight.
and this is I think
Volume.
constant, right?
Yeah.
The
Volume of the
milling
milling jar.
volume of milling bar. But
Minus
very careful with the milling bar. I'm sorry, milling balls.
Yeah.
Milling ball. I mean
Number
this.
of ball you
Yes.
have to calculate.
If you are careful enough, of course, the volume of milling jar, you just measure it one time in the
Yeah.
beginning. I usually ask Alif or my student, you just put water until
Yes.
up, and then 3 times, and then the average,
Yes.
just to make sure.
Yeah.
But this milling balls, it's we use the small milling ball. Then you measure the volume using the Archimedes method.
Yeah.
But you have to be careful. Once you measure it, keep it, not one ball missing. Because one ball missing means actually you change the volume, right?
Yes.
So if there's missing, then you have to measure again.
Yeah.
You just want to make sure that the balls are still
Same.
there,
Yes.
not even one missing.
Yeah.
Okay, then you already measured this, you have the weight of the
Yttrium hydrate.
lanthanum dihydrate powder. The
This one
temperature-
yttrium, no? This one is yttrium.
Yeah?
This is yttrium.
Yeah,
This is yttrium.
yttrium dihydrate. Yttrium dihydrate.
Yeah.
Now, regarding the temperature, initially I used exactly 25 centigrade
Okay.
or 278 Kelvin. But based on the actual experiment, like I show you here, for example, this is a good example. You see, this 25 is the minimum actually. Okay,
It
relatively
fluctuates
minimum.
between.
The highest could be like 30 something, less than 35. Okay, this is in centigrade. So I use the average of this, which is 28.1,
Okay.
convert that to Kelvin, and then
This why this fluctuation, Prof? Why is it increasing,
that's the
decreasing?
characteristic. Yes, that's actually this is
It's
very
a-
interesting.
is it noise?
Because I think that's kind of due to the cyclic movement could be. Why? Because I did the experiment with the empty milling jar. Empty milling jar, no balls, no
For
samples.
example,
The temperature is something like this.
same.
This
Yeah, up and down. And according to ideal gas law, once the temperature going up, the pressure as well. If you change the scale
Yes.
of this is actually like a harmonic.
Yeah.
This is the temperature, for example. This is the pressure.
Yes.
The temperature increases, the pressure increases.
Yes.
temperature downs, pressure downs.
Mm.
So based on this experiment, for example one, then I usually put for this calculation,
So, doctor, when you
the
start,
temperature is 28.1.
Prof, when you start the milling process, ball milling process, automatically the temperature would.
So actually, if you see this, it will change whatever this value you put it, right? It changes. You put, for example, this is 25 centigrade, and then but it should be in Kelvin, 278. It's different this value when you put 28.1, right?
Right.
It changes. It changes the value a little bit, a little bit. So regarding the temperature, it's actually the ambient temperature, but 25 centigrade, based on the previous experience here, 25 is the lowest good. So then based on this is very long time. You see that this is in hours. Then I usually take the average of the previous experiments, and that was 28.1 or 28. 28 centigrade, and then convert that Kelvin, and then you put to this formula, then you get this. Then why I use Excel, you can change the weight, 1 gram, 2 gram, 3 gram, then it changes. That's why you need Excel, like what I...
This constant, this is a constant, right?
The constant is, you put it into the formula in Excel, right?
Okay.
You make the column of weight, the column for milling jar volume, the column for milling ball.
This constant vary according to the material. Is it-
Actually, in the sense of material, is actually this. You can imagine the PP and RT, right? PP and RT. If you
Here I have paper.
So, doctor, the temperature is the T is fixed, right?
Okay. So actually, this is actually not too complicated. Okay. You remember this PV and RT, right?
Yes.
PV and RT. And then we position the formula. You measure directly, convert that to liter. Not cc, not centimeter cubic, not decimeter cubic. Decimeter cubic and liter is the same actually. Yeah, but it should be in liter. So that's why when I ask my students, okay, what is the volume? I don't want to make them confused. I just accept what they measure, and then I just convert that by myself to liters, like that. So actually, this is easy to use.
Yeah.
I suggest you, for example, why I make this Excel. It's actually this. You see, this is weight. So
That's that's what we're going to vary, like,
1,
doctor.
2, 3. I just put it, and
Okay.
then
Right,
the pressure of the hydrogen. And then my version is too many columns. Actually, what you need is what's stated here.
Weight and
Yeah. Of course, temperature still depending on us.
Yeah.
You want to use 25 centigrade, 28, 29, based on your judgment.
Yeah.
My
This equipment,
judgment is,
you can vary the temperature up to.
yeah, because it's actually the temperature inside the milling jar during the process, right?
During the process.
You're not
Varying.
inducing the temperature, or you're controlling the temperature.
No. Actually, what we
Okay.
we measure, but we don't make the temperature as the
Variable.
independent variable. Independent
Ah.
variable. No.
Okay.
Yeah, we just setting.
Okay.
Yeah. So this is you just include the temperature in this formula.
Okay.
Okay. Now, what temperature? Of course, it depends on our judgment. What's the range of the temperature? For myself, I use this. For example, this is one of my previous experiment. So the temperature is this. Okay. So initially I used 25 centigrade, and then the next experiment I used 28.1. 28.1 is the average. of this. So that's what I did. So then I think it's easy to do.
Yeah.
It's easy to do.
So we're just going to vary the weight
Yeah.
of the powder. That's it.
Yeah, for example, you want to begin with, let's say later on in Malaysia, you want to begin with 1 gram. Yeah, you already had an Excel, put 1 gram, and then what is the
Out.
pressure of the hydrogen? Like that. But this is for YH2. The number is different. If you remember this, and then I changed to lanthanum dihydrate. You see,
Yeah, different.
because why this? This is the density.
different.
So this is where the thing that related to the material,
Yes.
the density, and for this is the molecular weight.
Yes,
So this is the one that relates to material,
correct.
and everything already converted into this one. You just use. I think
So we vary the weight, we get different pressure.
yeah. You just made. For me, I also make the column for this. In case later on something changes in volume, I don't know.
Yeah.
Maybe you change the milling jar, or that's what I
The
said.
ball.
Ball missing. When ball missing, very difficult when you didn't realize the ball is missing. You just keep thinking that it's the same
Everything
ball,
is okay.
the number. Okay, but I had an experience at the last minute when I poured down the milling balls. Two or three balls is
Yes.
coming out, and I cannot use this volume anymore.
Yeah.
Because what I put is different volume.
Yeah.
The diameter of the ball, does it affect the pressure?
Okay. You can, shortly speaking, is this.
Smaller the diameter.
Usually the in the milling balls, usually this ratio is very important. The ratio of over the weight of the sample. They use this to the every
10 is to
yeah.
1, around 10 is to 1.
It's I think more than one, right? The weight the weight of sample. Yeah. The weight of sample.
1 gram, this one will be
yeah,
10
of
gram.
course it depends. Could be less than milling ball.
Yeah.
When it's less,
But-
then it's less than 1, right?
Yeah.
Okay.
No,
But-
this will be higher, this is lower.
Yeah.
So this will be more than 1.
In our case,
Uh-huh. Oh, the sample will be more heavy.
let me show you this. I show you this. Okay, this is what. You see this. Initial weight. This is the Sophia.
Yeah.
It says lanthanum hydroxide, not YH2, not LH2. 8 gram. Okay, and then using the formula for lanthanum hydroxide, then for this 8 gram, the pressure of hydrogen is 9.4. Okay, 9.4 at the time. And then the rotation we use for the experiment for Sophia is 180.
Any particular reason, doctor? Why 180?
Yeah, 180. Yeah, it could be changed. It depends on the capability of your device.
Okay.
Okay, I think for example the device, your planetary ball milling, please check the range of the appropriate rotation.
Okay.
You cannot. There's a maximum rotation. It depends on each
Right.
device.
Yes.
Okay. Let's say, for example, if I were you, let's say once you go back to Malaysia, and okay, our planetary ball mill can maximum, okay, with the safety precaution, let's say 300 RPM. Then, okay, put that 300 RPM as the maximum. Then you can use RPM as the variable, 100, 150, 200, 250.
All
You understand
right.
what I mean?
I
That is
understood.
also okay. So this is what I did. This is what I put this in my logbook.
Okay.
In my logbook. So something like that. You see that this is for this is the reaction. What's
Yeah.
okay? The number is different. The number is different for lanthanum
Hydroxide.
hydroxide. Yeah, because it depends on the molecular weight, depend on the density of the lanthanum hydroxide. So you see what I did is just simply everything is already weighed. Okay, the temperature, why this is more than this is like until 857, because I already put this temperature in the form of Kelvin. Yes. So at that time, my judgment was using this temperature for the calculation, convert that to Kelvin, and then put that in the similar formula. But for this, then I got this.
Okay.
And it is better you in the beginning make a Excel for that. Let's say you want to try from 1 gram until 10 gram. Then the pressure is calculated.
Yes.
Okay. You just put the formula in the Excel, right?
Yes. Okay.
So that's you can do the experiment based on that. You don't have to calculate every time you want to do the experiment. You already put it in the Excel.
So we use that pressure for the
To get the pressure.
Okay.
This pressure is the pressure that of hydrogen that you should
put in, yeah.
inside the milling jar.
Yep. Okay.
Okay. So now the mechanism is this. If you I show you again this just to make sure. This one. Okay. Okay. This is the powder that you already measure. You want to use 1 gram, 2 gram, and then on the paper you already calculate it, or in Excel what is the pressure of hydrogen.
Yes.
First, what you should do is you put this powder, okay, and the milling balls, whose volume already measured, put it inside, close, okay. After you close, okay, you should realize that there is still air inside. So you have to vacuum out the air.
Correct.
Okay. How do you know that when the air also already vacuumed out? You remember that there is this
Pressure.
when this says 0, when you pump out the air, it means 0
Or
pressure.
10 power minus 4 Pascal.
Yeah, I usually when I vacuum out the air using the compressor, I just read when this is already 0, just I stop. It means it's already 0.
Okay.
Please also realize that this and the vacuuming out the air using the compressor is we call it rough vacuuming. So I mean when it says 0 here, so we just believe it's 0.
Yeah.
But if you use the very more detailed, more very meticulous manometer, it could be still some air there. But I think this is enough for us. Once the air is vacuumed out, then put the hydrogen inside. How much? You read this, and usually this meter of the flow or the amount of hydrogen gas in the form of bar, in the unit of bar. That's why I use bar. Bar. When you put this, okay, you can see how much of it, of course, first from here. But this is to coerce the scale. You cannot see. Let's say you need, for example, 9.4. You can see number 9, but 0.4 is very difficult to see the position. Then what you can do is you can see here and here the amount that hydrogen pressure getting inside, right? 9.4 here. I did that. Okay, when it's already 9.4, you close it. For example, 9.4. Okay, then you bring this to this planetary ball milling, and then turn on the machine.
Very clear.
Yeah. But you get what I mean.
Yes.
Yeah. So actually, not too difficult actually, not too difficult. Okay. So actually, close the lid, vacuum out the air. When it's already 0 bar in the manometer digital manometer, you put the hydrogen gas. How much the pressure according to the calculation.
Yes. Okay.
As simply as that.
Right.
Okay. Then you put it in the planetary ball mill, and then turn it on.
Okay.
And assuming you already you also setting up this wireless monitoring for temperature and pressure, then you can just directly see through internet the change in the pressure and the temperature. For example, like in presentation. I'm sorry, here. You see this? This is the diagram of pressure, temperature, time. This is the one that you monitor wirelessly.
Yes.
Okay, something like that. You see that? This is fluctuating. This is the pressure. Okay, the temperature is something like still 25 and then 30. You see that? This is the reading. This software is open source. You can use it online. You have to register.
What's
Oh, okay.
Yeah.
person?
Yeah, I think this is from Mr.
Henry,
Harry.
I asked Henry.
Mr. Harry is doing that. Yeah. So then you can monitor it wirelessly.
Okay.